So let's take the first question there under the Mass 106 examination question. And this is 2023. And I have the question here with me. So the first question there, we are asked to evaluate the limits as x approaches 0 of tan x cos x over x. And the second one is this, and also the third one is this. So we are going to begin with the first one. So the first one there asks us to evaluate the limits as x approaches 0 of tan x cos x over x. And of course, if you look at these given limits, you will observe that if we should substitute 0 directly here, we are going to have tan 0, which is undefined, and also cos 0, or rather, we are going to have tan 0 cos 0 over 0. And of course, anything divided by 0 is undefined. So we don't want an indeterminate form here. So we are not going to be substituting we are not going to be substituting x equal to 0 directly into the limit. So what we are going to do is to rearrange the limit, or we are going to rearrange the limit, because we know that tan x, take note, tan x is equal to sine x over cos x, sine x over cos x. So if we substitute tan x equals sine x over cos x, we are going to have the limit as x approaches 0 of tan x now becomes sine x over cos x, sine x over cos x, then multiplied by cos x, and the whole of this is dividing x. So if you observe cos x, we cancel out cos x. So what we are going to be having here is the limit as x approaches 0 of sine x over x. And please take note, in limit, the limit as x approaches 0 of sine x over x is equal to 1. Now, if you want to know the reason or the proof, you can check on the description, or I'm going to send the link later for this very particular part. The limit as x approaches 0 of sine x over x is equal to 1. It is not given, it is actually being derived or being proved. But for the sake of this question, we are going to know that the limit as x approaches 0 of sine x over x is equal to 1. Please do well to watch that video for this. So therefore, the limit as x approaches 0 of tan x cos x over x is equal to 1. So for the sake of your exam, if you evaluate any limit and you come across, if you evaluate any limit to this form, just put 1. You don't need to start showing how the limit of sine x over x approaches 1. But to know the reason, you can do well to watch that very video to see the reason why sine x over x, if you take the limit as x approaches 0, is equal to 1. So let's move on to the second question, II. We are asked to evaluate the limits as x approaches 7 of x squared minus 49 over x minus 7. And of course, again, if we should substitute x equal to 7 here, we are going to have 7 squared, which is 49, minus 49, which will give us 0. And here also 7 minus 7, which will give us 0. So we are going to have 0 over 0, which is undefined. Remember, we don't want an indeterminate form in our limit. So what we are going to do, we are going to factorize the numerator. We know that this can be written as, the numerator can be written as the limit as x approaches 7 of x squared minus 7 squared over x minus 7. We can rewrite the numerator as x squared minus 7 squared over x minus 7. And of course, we know that if we have a squared minus b squared, this is the same thing as saying a minus b into a plus b, which is known as the difference of two squares. If you have this form, then it can be written as a minus b into a plus b. So we are going to apply that same principle here. Our a now is x and our b is 7. So it means that this limit, the limit as x approaches 7 of x squared minus 7 squared over x minus 7 can be written as x minus b. Our b now is 7. X minus 7 all into x plus 7 over x minus 7. So we have this. And if you should observe again, x minus 7 will cancel out x minus 7. So what we are going to be having here is, the limit as x approaches 7 of x plus 7. Then we can go ahead now and substitute the value of x into the given function. So what we are going to be having here is 7 plus 7, which is equal to 14. So therefore, the limit as x approaches 7 of the given question, x squared minus 49 over x minus 7 is equal to 14. So let's take the third question before we move on to the B part of the question. Third question there says the limit as x approaches 1 of 2x to the third power minus 5x squared plus x. Because this is a polynomial function, so we can substitute the value of x directly. Take note, if you have a polynomial function or a quadratic function or a linear function, you can directly substitute the value of x into that given function and you are going to get your limits. So what we are going to be having here is the limit as x approaches 1 of, the limit as x approaches 1 of, okay, we can directly substitute our value. Since this is a polynomial function, we can directly substitute x equal to 1 into the given function. So what we are going to have here is 2 into 1 cube minus 5 into 1 square plus 1, and this is going to give us 1 raised to the power of 3 is 1, 1 times 2 is 2, so we have 1 to the power of 2 is 1, 1 times 5 is 5, 2 minus 5 plus 1, and this is going to give us minus 2. Therefore, the limit as x approaches 1 of 2x cubed minus 5x squared plus 1 is equal to minus 2. Alright, so this is the answer to that given question 1a. So let's take the question 1b before we move on to the next question 2. All right. So in question 1b, we are asked to find dy dx from the first principle, given that y is equal to x cubed plus 2x squared plus x minus 4. Using the first principle, we want to find the derivative of this given function. So please, um, for the sake of this video, please, you can do well to watch my previous video on first principle in details. So for this very video, we are going to be very fast in solving this question. So we have y equal to x cubed plus 2x squared plus x minus 4. And we have to solve this using the first principle. And please take note, for the first principle, first thing we are going to do is to add increase in y to the left hand side and increase in x to the right hand side. In place of x, we add x plus increase in x, and in place of y, we add y plus increase in y. So our first start there is to add increase in y there. So we have y plus increase in y. And to the right hand side, in place of x, we add x plus increase in x. So we have x plus increase in x to the power of 3 plus 2. In place of x, we add x plus increase in x to the power of 2. Then plus, in place of x, we add x plus increase in x. Then the last one there is minus 4. So what we are going to do here is to expand this very brackets and also expand this. So expanding this, let's expand this over here. So we have x plus increase in x to the power of 3. It means we are going to have 3 terms of x plus increase in x. So we have x plus increase in x into x plus increase in x. So we are going to multiply these two terms first. X times x give us x squared plus x increase in x plus x increase in x. Increase in x times increase in x will give us plus increase in x squared. Then the whole of this will multiply x plus increase in x. So let's simplify this. We have x squared plus increase in x plus x plus increase in x will give us 2x increase in x plus increase in x squared. The whole of this will multiply x plus increase in x. So let's multiply this out now. X squared times x will give us x cubed. X squared times increase in x will give us x squared increase in x. 2x increase in x times x will give us 2x squared increase in x. 2x increase in x times increase in x will give us 2x increase in x squared. The next one there is increase in x squared times x. That will give us x increase in x squared. Then increase in x squared times increase in x will give us increase in x to the power of 3. So what we are going to be having here is x cubed plus x squared increase in x plus 2x squared increase in x. These two are the same. This is 1, this is 2. So if we add them up, we have 3. 3x squared increase in x. The next one we have here is 2x increase in x squared plus x increase in x squared. These two are also the same. This is 2, this is 1. So if we add them up, we have 3 plus 3x increase in x squared plus increase in x to the power of 3. So this is what we are going to substitute in place of this. we are going to substitute here. So let's quickly substitute that. We have y plus increase in y, and this will be equal to the whole of this gave us that. So we have x cubed plus 3x square increase in x plus 3x increase in x square plus increase in x cube. Now let's expand x plus increase in x square. Let's quickly expand x plus increase in x square. So this is the same thing as saying x plus increase in x into x plus increase in x. So we are going to have multiply this out. We have x square plus x increase in x plus x increase in x plus increase in x square. So we have x square plus add this to 2x increase in x plus increase in x square. So in place of x plus increase in x square, we are going to replace this. So let's replace that here, but this is 2 already. So we have plus 2 into the whole of this becomes x square plus 2x increase in x plus increase in x square. Then the next one we have there is x plus increase in x plus x plus increase in x minus 4. So let's open these brackets and write everything down here and see what we have. What we are going to be having is y plus increase in y. This is equal to, we have x cubed here. So we have x cubed plus 3x square increase in x plus 3x increase in x square. The next one there we have is plus increase in x cube. The next term there is 2 times x square. This will give us plus 2x square. The next one is 2 times 2x increase in x. This will give us plus 4x increase in x. The next one is 2 times increase in x square will give us plus 2 increase in x square. The next one there is plus x plus increase in x minus 4. Our next task there is to send y over to this side to express it in terms of increase in y. So if y comes to this side, becomes minus y. So what we have there is increase in y equal to x cubed plus 3x square increase in x plus 3x increase in x square plus increase in x cubed plus 2x square plus 4x increase in x. Next one there is plus 2 increase in x square plus x plus increase in x minus 4. Then y crossover becomes minus y. So the next thing we are going to do is, we know what y is. From the question, y is equal to x cubed plus 2x squared plus x minus 4. So we are going to, in place of y there, we are going to substitute this. So what we have is increase in y equal to x cubed plus 2x plus 3 plus 3x square increase in x plus 3x increase in x square plus increase in x cube plus 2x square plus 2x square plus 4x increase in x plus 2 increase in x square plus x plus increase in x minus 4, then minus y. Now we know what y is. Y is the whole of this. So we have x cubed plus 2x squared plus x minus 4. So our next task there is to open this bracket. Open this bracket. So what we have is increase in y equal to x cubed plus 3x squared change in x plus 3x change in x squared plus change in x cubed plus 2x squared. The next one we have there is plus 4x change in x plus 2x change in x squared plus x plus change in x minus 4. Then what we have next is we are going to use this minus to open the bracket. So what we have here is minus x cubed minus times plus minus minus 2x squared minus times plus minus x, then minus times minus plus 4. So what we are going to do now is to cancel out. If you observe, minus x cubed, we cancel out x cubed. The next one there is minus 2x squared, we cancel out plus 2x squared. Another one there is minus x, we cancel out plus x, and 4, we cancel out minus 4. So let's rewrite what we have now. Let's quickly rewrite what we have. So we are going to have increase in y to be equal to 3x squared increase in x, 3x squared increase in x plus 3x increase in x squared. And the next one there is plus increase in x cubed. The next one we have there is plus 4x increase in x plus 4x increase in x, and our next one is plus 2x increase in x squared plus 2x increase in x squared, and our next one there is plus increase in x plus increase in x. And is that all? Yes, that is all. So this is what we have. Now, having obtained this, our next task is to find increase in y over increase in x. So what are we going to do? We are going to divide each term by increase in x. So divide this, you have increase in y over increase in x. And this is equal to, you divide each term. So we have 3x squared increase in x over increase in x plus 3x increase in x squared over increase in x plus increase in x cubed over increase in x plus 4x increase in x over increase in x. Then the next one there is plus 2x increase in x squared over increase in x plus increase in x over increase in x. So what we are going to do is to cancel out them. Increase in x, we cancel out increase in x. Increase in x, we cancel out one of the increase in x. So we still have one increase in x here. Increase in x, we cancel out one. We still have 2 here. And increase in x, we cancel out increase in x. So we only have 4x here. Also, increase in x, we cancel out 1. We still have one increase in x. And increase in x, we cancel out increase in x. That is, increase in x divided by increase in x will just give us 1. So what we have here is increase in y over increase in x to be equal to 3x squared plus, if one of the increase in x cancel out 1, we have 3x increase in x plus increase in x squared plus 4x. The next one there is plus 2x increase in x, and then plus 1, because increase in x divided by itself will give us 1. So let's see our next task. So what we are going to be having there is, okay, having obtained this, our next task is to take the limits as increase in x approaches 0 of change in x over change in y over change in x. That is, we are going to take the limit of this. The limit as increase in x approaches 0 of increase in y over increase in x. We take the limit to the left hand side. We also take the limit here. So we are going to have the limit, as increase in x approaches 0 of what we have here, which is 3x squared plus 3x increase in x plus 3x increase in x plus increase in x squared plus 4 plus 4 plus 4x plus 2x increase in x plus 1. We close our brackets. And please take note, I said it in my previous video under first principle that whenever you take a limit as increase in x approaches 0 of increase in y over increase in x, automatically you have the y dx to the left hand side, and to the right hand side, in place of increase in x in the given function, what we are going to do is to substitute 0. So what we have here is 3x squared plus 3x into, we have 0 plus 0 squared plus 4x plus 2x into 0 plus 1. That's what we have. So dy dx will be equal to 3x squared. 3x times 0 is 0 plus 0. 0 squared is 0 plus 0 plus 4x plus 2x times 0 is 0 plus 1. So therefore, dy dx is equal to 3x squared plus 4x plus 1. And that is the answer to that given problem. So please, if you are new to this channel, do well to like the video, comment, and I promise to respond to everyone. And like the video, share, and subscribe. See you in the next question, number 2, still under the 2023 maths 106 exam question.